Hello everyone, welcome to my channel Twinkle Teaches, and here is your friend Twinkle. Hope you all are doing good with your studies. As we are discussing all about topology, here is the next topic in this list, that is subspace of a topological space, or subspace topology or relative topology. It is also known as relative topology. Now, X tau is a topological space and Y is a subset of X, or you can say it is any random subset of X. Now, in this video, we will check out what is the subspace topology defined on the set Y. So, let us start. If Y is a subset of X and tau Y is the collection of subsets of Y. As we have seen before when we were discussing topology on the set X, we have chosen the collection of subsets of X, or you can say it was the collection of subsets from the power set of X. That is the collection of all subsets of the set X. So here we will be dealing with collection of subsets of Y. And these are the subsets like G intersection Y. It means that tau Y, which will be known as the topology on the set Y, it will contain the elements like G intersection Y. That is the subset Y we have chosen from the set X and its intersection with the open sets of the set X. Open sets of X means the elements of the topology on the set X. As we know that each and every member of the set tau is an open set of the set X. Now G is your open set of X, and we are taking the intersection of this G with the subset of X as we have taken it is Y. So this types of members are contained in the set tau Y, which is the collection of subsets of Y, as well as it is the topology on the set Y. Now, let us come to the proper definition so that we will get what exactly the subspace topology is. Let X tau be a topological space and Y be any random subset of the set X. Then the collection tau Y, we have given this topology a special notation tau Y so as to identify that this tau Y is the topology on the set Y and simple tau is the topology on the supreme set, that is X. So here tau Y is the collection of members such that G intersection Y, here G is open sets of the set X, and this is the topology on Y, which is called subspace or relative topology of the topological space X tau. Here we can understand it as subspace of X means definitely Y is the subset of X and it is the topology on Y. So here we have a set X on which the topology tau is defined. We are picking some members from the set X and again we are defining topology on that set Y, and that topology is known as subspace topology or relative topology of the topological space X tau. The topological space Y tau Y, we are calling it topological space as simple tau or tau Y is the topology on the set, and we collectively Y and Ty called as topological space. Here tau Y, which is a simple topology on the set Y, is G intersection Y, where G belonging to tau. That means G is your open set. Open set means G is a subset of X as well as G belongs to tau. This means that G is your open set, and we are taking intersection of this G with the set Y, and this is the subspace of the topological space X tau. Now let us come to the example so that we can understand it easily. We are picking a set of 5 elements, that is X is equals to P, Q, R, S, T. These are the 5 members in the set X, and now we are defining a topology on it as phi and X are definitely the member of this topology on the set X, and the other members of the topology, they are P, R, S, P, R, S, Q, R, S, T, and you can verify it easily that this is the topology on the set P, Q, R, S, T. And now we are taking up a subset of the set X, that is PQR, containing 3 elements, and you can easily see it is a subset of X. Now we have to define a subspace topology on the set Y, and members of this tau Y are of the form G intersection Y, where G is the open set of X. So as we have seen, each and every member of tau is the open set of X. So what we are going to do is, so the criteria we are going to use is, we will pick members from this topology tau one by one and take the intersection with the members of Y. So as here we have to collect members like G intersection Y. So first member is phi intersection PQR. Here you can see first member is phi intersection PQR. Second member will be P intersection PQR. So here is your second member P intersection PQR. Similarly, we have to take intersection of each and every member of this tau with the Y. Now the set tau Y will contain the members like this. Now we will take the intersection of these sets one by one. Phi intersection PQR is again the set phi. Now the second member is P intersection PQR. So only P. So we have set P over here. The next member will be RS intersection PQR. Only R is common, so it will be singleton R. Now next member will be PRS intersection PQR. So 2 members are common here, they are P and R. So we have P and R. Now come to the next member, QRST intersection PQR. You can see QR, QR. Here 2 elements are common, they are Q and R. Come to the next, X intersection PQR. So we will be having whole Y. That is your set Y. PQR is your set Y. Now you can easily see that this topology is containing phi and Y, and they are the essential elements of any of the topology. By definition, you can understand it that if tau Y is a topology on the set Y, then phi and Y are definitely the member of this topology. Now after this example, let us come to some application of this subspace. If you are given a subspace of a space, it means that we have a subspace which is known to us, and we have given a subspace of this space and a set of that subset. Means that a member from this subspace, then you can identify it is open or not. It means to say that if X is any set and we are given a subspace Y is a subset of X, and again we are given a member A from this set Y, or you can say subset Y, then we can identify by the property of a subspace topology that if this member A is open or not. As here you can see, consider subspace Y is equals to closed 0, 1. This bracket is known as closed bracket. So Y is equals to 0, 1. We are given of the space RU, that is the usual topology on the set R. Then the question is 0, 1 by 2 in a closed open bracket, it is open or not? So definitely the answer is no, because it is not open in RU, but you can say that it is open in the lower limit topology RL, as it contains the member with the bracket 0, 1 by 2, which is closed open. I hope you all have got this subspace topology or our relative topology, and it is the build-up of the theories on topology, and one by one you will see more and more properties of the topological space. Recently you have seen the subspace. I have discussed previously what is the topological space, then we have discussed about subspace of it, and similarly we will discuss more and more topics related to topology. So stay tuned. If you have any suggestions and queries, you can ask me in the comment section, or you can provide it in the email ID given here. Don't forget to give it the thumbs up if you like it. Don't forget to subscribe and press the bell icon so that you will get notified whenever I post a new video. Thanks for watching. Enjoy learning.